Hi, I'm Prachi Damle, software engineer at Rancher Labs. Today I'll be demonstrating how to migrate an application running on Rancher 1.6 platform to Rancher 2.0. Rancher 1.6 uses Cattle as the base orchestration engine to orchestrate Docker containers, while Rancher 2.0 uses Kubernetes. Due to large technology differences between the two platforms, there is no straightforward upgrade path available. Thus, it is a challenge for Rancher 1.6 users to transition their applications to 2.0 platform. In this demo, I'll walk through how to transition the Docker Compose config files of a Rancher 1.6 application to Kubernetes YAML specs that can be deployed on Rancher 2.0 to achieve the same results. So let's get started. Here we have a Rancher 1.6 cattle environment. This is the default environment that is provided when you install Rancher 1.6. Let's look at the host present in my environment. We have two hosts here, and one of the hosts has a label, the key value pair being db equal to true. Let's take a look at the user stacks in my environment. I have a stack my app deployed. It has few services that are running in this stack. My application comprises of two services, the web service and the database service. Now the web service is running the SD Elements Let's Chat application, and this is a global service having two containers deployed. So one container per host is deployed by Rancher. Now other aspects of this service, we can take a look here. It is exposing its private container port 8080 onto the public host port 9890. Now the Let's Chat image depends on the Mongo container being available. So we are using a service link here using the alias name Mongo to point to the database service. This service also has a health check configured. It is using a TCP health check that makes sure that a TCP connection opens on its private port 8080. Here you can see that Cattle places the convenient link to its host port 9890, which takes you to the home page of this application. Now the other service, the database service, is running the latest Mongo image. This service is using a scheduling rule. It is using the host label affinity rule, and this is a soft affinity which is asking Cattle to try to schedule this service onto a host having the key value pair db equal to true, having the label db equal to true. Accordingly, Cattle has deployed this service onto my host having this label db true. Now, let's take a look at another feature of my stack. Another aspect of the stack is that I have configured a load balancer service to front the web service. The LB service uses the port rule with host name and path based routing. Let's take a look at that. So I have a port rule here which is using a host name myapp.chat.com and a path /login to route the traffic to my target web service in my stack and to the target port 8080. If you are a Cattle user, you know that Rancher 1.6 has this cool way of viewing all these deployment aspects of my stack using this option view config, which shows me the standard Docker Compose YAML file and the Rancher Compose YAML file, and it lists all the services running in my stack with all these deployment aspects. Just a note here that the Docker Compose YAML file consists of all the standard Docker constructs, while the Rancher Compose YAML file includes all the Rancher specific functionalities. For example, the health check and the load balancer configuration are all Rancher provided functionalities, and they are present in the Rancher Compose YAML file. Now next we will move on to how to transition this stack to Rancher 2.0 platform using these two Compose files. In order to deploy this app onto Rancher 2.0, which uses Kubernetes, we will need to transform these two YAML files into Kubernetes YAML specs. To do this, one can use the Compost Tool under Kubernetes repo. The Compost Tool consumes the Docker Compose files and creates the equivalent Kubernetes specs in YAML format. However, this Compost Tool does not understand Rancher Compose YAML constructs, as this file contains the Rancher specific functionality only. So we have built a migration helper tool. As you can see, here's the repo Rancher migration tools. This tool can parse the Docker Compose file and the Rancher Compose file, and it provides an output file which lists all the constructs for each service in your Docker Compose YAML file that will need to be handled specially to migrate your applications to Rancher 2.0. Kubernetes YAML specs are also generated by this tool, so it invokes the Compose tool internally and provides the Kubernetes YAML specs that you can use to get started with the migration. I have downloaded the migration tools. So let's run this tool over the Docker Compose YAML and the Rancher Compose YAML files that I have exported from my Rancher 1.6 setup. This is the output of the tool. What it generates is few files. First is the output.txt file, which lists all the Docker and Rancher constructs that we need to handle specially. That means we need to translate to equivalent Kubernetes constructs in YAML format. And it also generates the output of the Compose tool. So the Compose tool outputs few YAML files for each of the services in the Docker Compose YAML file. A little bit about this. A Rancher 1.6 service maps to a Kubernetes workload of a certain type. For example, a stateless service maps to a workload of type deployment, a global service maps to a workload of type daemon set, and so on. But these workload objects just specify the deployment rules for the pods that are launched for the workload. They themselves are not resolvable by DNS or to other objects in the cluster. So, to look up the workload and to access the workload, a Kubernetes service object needs to be created. A service provides a static endpoint to the pods. As in short, each Rancher 1.6 service in my stack translates to two objects. One is the workload object of a specific type, for example, a deployment or daemon set or stateful set, and a service object. Hence, the Compose has generated two files for each service in my stack. Now let's take a look at the output.txt file that the tool had generated. What it has is a service-wise list of Docker Compose or Rancher Compose constructs that the Compose tool has failed to parse. So we will need to take care of these constructs in order to achieve equivalent functionality on the Kubernetes platform on Rancher 2.0. So let's go over each services list and see how to add them in the Kubernetes YAML specs. Now let's take a look at the first service in our Docker Compose YAML file. It is the database service, and let's go through the list of Docker constructs that the tool has provided that we need to take care of in order to be able to launch this on 2.0. So before that, I'll explain what all these files are. So here we have the Docker Compose YAML file and Rancher Compose YAML file that we have downloaded from our 1.6 setup. In here we have the output.txt file, which is generated by the migration tools binary. Here is the database deployment YAML file, which is the Kubernetes YAML spec for the deployment object for the database service in our Docker Compose. So it has created this file. And lastly, in this window, we are going to edit this database deployment YAML generated by Compost Tool and add whatever is missing in order to take care of the missing constructs. So for the database service, coming back to the Docker Compose, what we have gone over is it's running the latest Mongo image, and it is using the soft host label affinity rule. Going to the output.txt, for the database service, these are the things we need to take a look at. So we have the labels, which are rancher specific labels that the Compost tool won't understand. So we are going to add the equivalent functionalities in our KTS YAML specs to take care of these. So the label io rancher.container.pull underscore image, it tells Rancher to always pull this Mongo image newly whenever this container is going to be deployed or redeployed. The equivalent tag in Kubernetes for this is in the deployment specs. In the container section, here is where we specify the image Mongo and name database for this deployment object. In here, you can add a tag called as image pull policy. So the edited database deployment YAML, I have added this tag image pull policy being always. So this is the equivalent of this rancher label io rancher container pull underscore image. The next thing to take care of is the io.rancher.scheduler.affinity host label soft affinity rule. So under all the constructs that are mentioned in this output.txt, the tool will also place a help link where you can go and check how to take care of this particular construct for Kubernetes. So these links are either blogs that we have on Rancher site or documentation on Rancher site, which will guide you for this particular construct. So for the scheduling rule label, iorancher.scheduler.affinity mentioning the soft host label affinity, what we can do is in the database deployment YAML spec, we add the Kubernetes affinity construct. So in the edited file, you can see that I have added the affinity construct under the deployment spec, under the container spec. In here, we mention the node affinity, which tells Kubernetes scheduler to select a node as per this affinity rule. Now this tag preferred during scheduling, ignored during execution, it means that the scheduler is going to try to find a host matching this rule, but it is not a hard rule. So this is equivalent to the soft affinity rule of our rancher label. As you can see in the rule we mentioned to choose a node which satisfies the label db equal to true. Thus, for the scheduling label of rancher, in Kubernetes spec, add the affinity construct. Other thing in my output.txt to take care of is scale. So If you're a Rancher 1.6 user, you know that in Rancher Compost.yaml, scale is a parameter that can be put in to tell Rancher how many containers should be launched for this image. In Kubernetes, the equivalent construct is replicas that you have to mention in the deployment spec. So the Compost tool output that you get out of the migration tool is going to have replica 0. You should edit the deployment YAML specs and mention the number of replicas that are required for your service. So I have in my edited YAML specs, I have put in the replicas as 1 since the scale for my database service is 1. Now lastly, in my output of the migration tool, I see that under the database service, start on create is mentioned. Now this is a Rancher parameter that you can place in Rancher compose.yaml file, and it is a Rancher provided functionality. What it means that when this flag is true, Rancher will start the container upon creating it. But you can also request Rancher to just create the container and not start it by putting the value as false. As of now, there is no equivalent method on Kubernetes to implement this functionality. Now, one thing I would like to mention is the deployment YAML specs that the Compost tool had generated had some extra things that are really not needed while we are deploying this application on Rancher 2.0 platform. So look at the database deployment YAML spec. Under metadata, the Compost tool has placed some annotations. This is nothing but all the labels it found in our Docker Compose spec and the compose command that created this file. So the annotations can be safely removed, as well as the creation timestamp is not needed. It will be populated after this deployment is created on your cluster. So in the edited database deployment spec, I have already removed these annotations. Then also, you can remember that I was using a stack called as my app on my Rancher 1.6 setup. The equivalent of a stack on Rancher 2.0 is the Kubernetes namespace, which is used to group the workloads you are deploying on your cluster. So I am mentioning the namespace as my app. So when I launch this YAML file onto Rancher 2.0, the workload gets deployed in a namespace called as my app, just like the service was deployed in the stack my app. Alright, so moving on to our second service in Docker Compose YAML, that is the web service. Let's take a look at what we need to take care of in the output file. First, we have the health check. So health check is a Rancher construct mentioned in the Rancher compose.yaml file under the web service. The equivalent method to configure the health checks on Kubernetes is specifying liveness and readiness probes for your container spec. So I've added the liveness probe and the readiness probe. Now the health check that we had used on our 1.6 setup was a TCP health check. This can be supported on Kubernetes by using the liveness and readiness probe of type TCP socket. Also, you can tune in your probes and configure what failure or success thresholds you want and the interval at which these probes should run. And this is similar to how you could tune in your health checks on Rancher in the Rancher Compose YAML file. Moving on, next we have to take care of the label pull image. I have added the corresponding Kubernetes construct image pull policy as always. The next label is io.rancher.scheduler.global. This label asks Rancher to deploy this service as a global service. Now, refer to the scheduling blog on Rancher site in order to know how you can take care of this in detail. So to make this workload global, what we need to do is change the kind of this workload object from deployment to a daemon set. Daemon set is a Kubernetes object which informs Kubernetes scheduler to start a pod for this deployment or for this workload on every node. So we change this deployment spec to be a daemon set in order to make our workload a global workload. The next thing to take care, along with changing the kind, is for the daemon set, few of the properties like replicas and strategy do not apply. So make sure you remove them from your spec. While we are here, I would like to mention, I've also mentioned the namespace myapp where this workload will belong to. And I've also removed the unnecessary annotations that the Compost tool had placed. Moving on, we have link mentioned in our docker compose.yaml file for our web service. This link has mentioned that we use the alias name Mongo to refer to the database service running in this stack. The way to take care of this Docker link in Kubernetes is by creating a service object pointing to the deployment or to the workload that you are trying to reach. You can read details about how to do this in the service discovery blog on the Rancher site. I can show you here the service object that we need to create in order to establish this DNS link. So what I have done is I have created a service object, so a Kubernetes YAML spec which mentions that I'm creating the kind service, and name of this service is Mongo. This name is nothing but the alias name I'm using in my Docker link, and I am pointing this service to the workload which has the tag IO Compose Service Database. So I'm using the selector label approach of Kubernetes, and I am pointing this service to the database deployment workload object. So the database object or the database deployment is using the label io.compose.service:database, and I am selecting that object by using this selector in my service. One thing I would like to mention is ports is a required field in the Kubernetes service object. So you need to mention a port which your container is exposing. It is the private port of your container, just in order to satisfy the Kubernetes validation. So after we run this Mongo service on the Kubernetes cluster, what we are creating is a way to access the database deployment by using the name Mongo. This is equivalent to creating the alias name Mongo for the database service, the 1.6 way. Okay, so the next thing is ports. So my service on Rancher 1.6 is exposing the container port 8080 to the public host port 9890. In Kubernetes, to do this, you can specify the host port in your deployment or daemon set object under the container spec. So in my container spec, I added the port section, and I mentioned that the container port 8080 is to be exposed on the host port 9890. There is another way of exposing the container port in Kubernetes, and that is by using node port. You can go ahead and read about details of node port on the Kubernetes documentation, or the blog on Rancher site will describe what the node port is and when you can use this. Moving on, the start on create parameter of Rancher, as mentioned earlier, cannot be migrated to Kubernetes platform right now. Further, we had the load balancer service in our Rancher 1.6 stack. Now, there are various ways of implementing load balancing in Kubernetes, and for that you can refer to the load balancing options blog on Rancher site. Today I'll demonstrate how to load balance this application by using Kubernetes ingress. The Kubernetes ingress specifies the load balancer configuration. So it is just a specification. I have created this ingress object YAML spec here. It mentions that the kind is ingress, and it also specifies the load balancing rules that I want to configure. You can see that just like the 1.6 lb config in the Rancher Compose YAML file, which mentioned the host name and path-based routing, the ingress spec also can carry the hostname path-based routing rules. So I have specified my host myapp.chat.com and the path /login, and the target for this rule is going to be the backend section, which mentions the service name web with the service port 8080. It means that a service object called as web needs to be present in the Kubernetes cluster. Now, here you see the web service. This is also generated by Compost Tool. So the name of this service is web, which the ingress is going to target. And the service is pointing at the workload using the selector label approach. By creating this ingress specification, the ingress controller running in your Kubernetes cluster is going to configure the load balancer and set up the routing rules. So these are the three services running in my Rancher 1.6 stacks, and this is how I have converted them to the Kubernetes YAML specs. Let's move on to deploy these YAML specs onto the Rancher 2.0 platform and see how my application gets migrated. Now this is my latest 2.1 setup where we will deploy the Kubernetes YAML specs that we just created. Upon login, you come to this global view where all the Kubernetes clusters you have added via Rancher server are listed. I have one cluster created here. Let's drill down. In my cluster, let's take a look at the nodes that I have. I have 3 worker nodes where all my workloads will get deployed. One of the node I have labeled using the db equal to true label. Now, let's take a look at the project namespaces tab. The term stack from Rancher 1.6 maps to the Kubernetes concept of namespaces. So I will create the namespace my app here in this cluster, under which we will deploy all our workloads. Now under the cluster, Rancher users can create projects. By default, Rancher creates a default project under your cluster. Project is an organizational entity introduced by Rancher to manage a group of namespaces together. A project helps with the administration of user access to various resources in your cluster, and it can be used to implement multi-tenancy. Thus, the compute nodes belong to the cluster, but the administration and access of all your resources can be implemented at the project level. So together, the cluster and project is equivalent to an environment in Rancher 1.6. Now let's go to the default project in my cluster and see how we can deploy the workloads. Here under the workloads tab, you can use the deploy functionality and you can specify the workloads that you want to deploy under your project. Other way is by importing Kubernetes YAML specs to the namespace of your choice. So the YAMLs that we have just created, we can upload here directly to the namespace myapp to migrate the 1.6 application. But there is another way as well to deploy the YAML specs, and that is via the Rancher CLI. I'll demonstrate how to use Rancher CLI and migrate the application on to this Kubernetes cluster in my 2.2 setup. So for that, let's download the Rancher CLI and get started. Now I've downloaded the Rancher CLI here. The first step is to configure the CLI to work against the Rancher server and the Kubernetes cluster that we have. For that, we have to run this command login and provide the API key token that one can obtain from the Rancher server UI at this location. So you can create API and keys and add a token for your CLI access. So let's log in against the Rancher server. As my CLI is configured to work against the default project in my Rancher 2.1 setup. Now let's proceed to deploy the Kubernetes YAML specs that we created. Now I'm going to deploy the first service, the database service, to my cluster using the CLI. So this is the command to apply the YAML file that we created to our cluster. So the Rancher CLI basically calls the kubectl create command internally. So our deployment database has got created. Next, we can create the Mongo service, which provided the public access to the database workload by the name Mongo. Next, we can go ahead with the web service, that is the second service that was in the 1.6 stack. So this is a daemon set, so it will be created on all nodes. We also have the service object for this daemon set. Now so far we have deployed our database and web services. Now let's take a look at the Rancher UI to see how these workloads got deployed. So I can see that my database service got migrated to 2.0 using the YAML spec, as well as the web service is up and running. So it says 1 per node, so it is like the global service in my 1.6 setup. 3 pods got created since I had 3 nodes in my cluster. Now let's see the public access that we had provided using the host port. So yeah, we are able to access the web service on the host port 9890. Now the third service in my stack was the load balancer service. Let's proceed to deploy that. For the load balancer service in the 1.6 stack, we had created a Kubernetes ingress spec. So let's deploy that using CLI. So ingress got created. Let's take a look at the UI. Under the project, there's a load balancing tab which will list all the ingresses that we create. So here's the ingress that we added with the host name myapp.chat.com and the path /login pointing to the workload web. It's still in initializing state. Okay, now the ingress has reached the active state. So let's see if we can reach the web service using this host name and path. To demonstrate this, we can simply use the curl command. First, I need to know what is the ingress address. That is the load balancer address that is fronting my web service. To do that, we can use the CLI and run the kubectl describe command. Name of my ingress is weblb and the namespace that we have used always is my app. So this is the ingress that we created. It has the ingress addresses that we can use to reach the service. So let's pick one of them. And it also shows the ingress rules, host name and path that we have configured. So let's just use the curl command to reach to the web service. Host is going to be myapp.chat.com that we have specified in our ingress spec. And we are trying to reach the ingress address and the path login. Let's see if we can reach the home page of our service. Yep. So here it could reach the Let's Chat homepage using the ingress address. Thus, we were able to migrate all our services in the Rancher 1.6 stack to Rancher 2.0 namespace and also provide a load balancing solution using Kubernetes ingress to it. So this is the way our Rancher 1.6 applications can be successfully migrated to the Rancher 2.0 Kubernetes platform. With this, I end my demonstration. Hope this walkthrough is useful to the Rancher 1.6 community to move on to Rancher 2.0 and successfully migrate the applications to the Rancher 2.0 platform. Thank you.